If you worked at all with video encoding, you've probably heard a bunch of different terms getting tossed around. Stuff like CBR versus VBR, and maybe in this you've heard that there's one pass versus two pass encoding. And if you worked in particular with FFMpeg, you may have also heard of terms like CRF and CQP. What are all of these? How do they affect your video? And which should you use? In this video, I would like to discuss what these all mean and their different advantages and disadvantages. So let's start with the simplest. If we consider video like a sequence of images, you probably have seen that JPEG images, so say it's a JPEG image, can have a quality percentage given to them, 0 to 100. Usually use around 70 to 90% for it to look good. And you will notice that if you drop this percentage, the image tends to get very particularly blocky. And this is just because JPEG uses the 8x8 macro blocks. The equivalent of this in video is CQP. CQP is constant quantization parameter. And in short, it means that each block of your video will get roughly the same amount of compression. So what this means is that your video it's roughly like always encoding with a particular JPEG quality. It's going to come out to a particular quality. Now, it turns out that this is not particularly efficient for two reasons. First, it's not constant either, and that's because the amount of information changes. If I am encoding a white, like just a regular empty frame, there's obviously going to be a lot less information than if it's like a full video. So it doesn't achieve that goal, but it's also not very efficient. And that's because whether the image is still or whether there's a lot of movement, we're giving it roughly the same compression data loss. Now, this isn't particularly efficient because it turns out that if stuff is moving rapidly on screen, the human eye is not very good at picking up on key detail. But whereas if something is standing still, we are very good at picking up all of the details. So what we would actually like is for if something is standing still, give it more bits. And if something's moving, well, you're not going to notice it anyway. Now, that'll lead to CRF. But I'd first like to go over the two main categories. So the two main categories we have is CBR, which is a constant bitrate, and VBR, which is variable bitrate. Now, first let's start with CBR. You've probably heard of CBR if you were streaming video, because both YouTube and Twitch recommend a video bitrate of around 6,000 kilobits per second constant. Now, what does this mean? CBR being constant means that each chunk of video is going to get roughly the same amount of bits given to it. So if I have like a frame video here, if there's a lot of motion, we're still giving it 6,000 kilobits. And if there's not a lot of motion, we're still giving it 6,000 kilobits. Now, the reason for this is CBR is very, very common in streaming or broadcast video. And that's because in these mediums, you don't want a lot of variance. For example, if you are streaming to a particular given website, you don't want the network usage to suddenly shoot up from 100 kilobits to, say, 17,000 or something, because most people's internet connections won't be able to keep up. You would rather have something that's always running at a constant rate than something that changes. So it's great for streaming applications. This is why broadcast television, which is based on satellite TV and so on, is also based on CBR, albeit at higher bit rates compared to streaming. Now, there's a very notable downside to this, and it's that it's very inefficient and your file sizes are very large. That's because if there's not a lot of things that are moving in the frame, we don't need very many bits to encode it, right? Versus if there's a lot happening in frame, you need a lot more bits. For example, this is why if you have a screen capture of a terminal, it's going to look really crisp at 6,000. If you're playing a game though, and you're constantly turning around, 6,000 probably not going to be enough, and you're going to start seeing artifacting, such as blocking, as we saw with JPEG. Now, what do we do then? Well, that leads to the second alternative, which is VBR, variable bitrate. Now, there are a couple classes of VBR. So one of the best examples is CRF. CRF on FFMpeg stands for constant rate factor. And it's great if you're trying to target a particular quality, but not a particular bitrate. What CRF will do is it'll analyze your frame, it'll search through it for motion, and if it, based on the detail it sees in the frame, it's going to dynamically adjust the bitrate. Now, CRF is better than something like one-pass VBR, since essentially there is no cap. It'll allocate as many bits as it needs to. And CRF is also better than CQP, because unlike CQP, where we were applying the same amount of blocking, same amount of compression to each frame, CRF will look at the type of video content. So if it's an empty video frame, it's going to give it all the bits it needs so that it looks crisp, because if something is still, the human eye is very good at picking out the key details. This is opposed to if there's a lot happening in frame, chances are you're not going to be able to notice any of those key details as much. So CRF will then allocate less than the ideal amount of bits that it would otherwise require. Now, I just said that CRF is pretty much constant quality, but now I'm saying that it's changing qualities. Well, it's actually a constant perceived quality. It's designed so that no matter what's happening in the video, video that's encoded at a particular CRF looks roughly the same quality to our eyes. Now, CRF usually goes from low values like 1 all the way to high values like 60. And the way it works is the lower is better and higher values are smaller. So if I have a CRF of, so for something like X264, the recommended values are 23 as the default for most uses, and 18 is generally considered to be visually lossless. Each plus or minus 6 you add generally doubles or halves the file size. Now, CRF is good and all, but it can lead to some very large files if you're just blindly following it. But I would still recommend it for most applications. If you're trying to target a particular quality, if you're, say, encoding video, you should go for CRF. Next is one-pass encoding. One-pass encoding is essentially like CRF, but we put a cap on the bitrate. It's also sometimes called constrained bitrate. Mind you, all one-pass means is that we do one pass through the video. So if here's my video from start to end, we are going to do one pass through it and do any detection, anything we need to, all in that one run. So one pass can be used to do CBR, constant bitrate. That's pretty obvious. You just always allocate the same number of bits as you go and figure out what quality you need. It can also be used with constrained bitrate. So what that means is we're going to essentially use a model that's like CRF to determine the rough quality. So our first, so in the first pass, we're going to look at the quality and then determine how many bits we need to allocate and then cap it. So look at the quality and then give it a max bitrate we can give. Now, one pass is usually, it's good if you want to achieve roughly the same file size and the same quality for, say, a group of videos. Now, for applications like X265 or for H265, so in particular for like libx265, generally you try to avoid one pass. And that's just because the quality doesn't go out as good as it could. If you care about quality, you should just use CRF. Now there's an alternative to this, and that's two pass. And two pass is very similar to CRF in that the difference is it's going to do two separate runs through the video. So it's going to be a lot slower to do. But what it will do is in the first pass, so let's describe this. So our first pass, we're going to analyze the video. What does this mean? Just like how CRF looks for the video complexity as it runs, we're going to run through the video and analyze it to see which scenes so we're going to look for particular scenes where we might need to allocate more bits. And in the second pass, we're going to adjust the bitrate. Now, two pass is great at if you want to hit a particular file size. If you know, for example, that you want your resulting video file to be roughly 1 gigabyte, say, for example, well, we know how many bits we have to work with. So what we can do is in the first part of the video, look at which scenes are more complicated, where we will need to spend the majority of those bits. And then in the second pass, since we know what it needs to add up to, we can just allocate those bits accordingly. So two pass can almost always hit a particular target file size. This is, again, as opposed to something like CRF or one pass, where you don't necessarily have a file size. With one pass, you can give it a constraint. And so let's draw out. If I plot my bitrate versus time, first let's draw CBR, because it's very easy. CBR, always the same. Say this is like 6 megabits per second. It's going to always allocate the same amount to it. CRF is going to always change. So it's going to, like, the bitrate can wobble, maybe it's low here, high here. It's going to have plenty of fluctuations. Now, what changes though is, say for example, my video had a complex, then easy, then complex, then easy part, right? My quality will remain fixed. So if this is my quality color versus this one where the video is hard, quality is bad. And then if I'm following the same example, if my video is now simple, boom, the quality shoots up. Video gets complicated, the quality goes down, so on and so forth. So this is going to keep the same bitrate, but the quality will change depending on what's on screen. This will, so this is CBR, this is CRF. CRF will keep the same quality, change the bitrate. Now, what happens with one pass? Well, the bitrate with one pass is also going to fluctuate, but say we're starting fine, we go down, but we really want to shoot up, but we can't. So what's going to happen is we pick a bitrate here, that's like our target, and no matter what happens, we're going to tell it, do not exceed this. So our quality will be pretty consistent, you know, as long as we're below it, we're doing it. Here, you know, we should have actually gotten like up here, say for example, the quality drops, but then it recovers. This is a very common scheme for H.264 video. The way you would do this in H.264 actually, so this is one pass. The way you do this is if you give FFmpeg both a CRF plus a video bitrate, it'll automatically do it in one pass. To do two pass, you actually provide dash pass 1, dash pass 2. So let's take a look at two pass. With two pass, we first are going to do our run of the video, and we're going to figure out what the quality we need is. Right, so we're going to look at what the quality we want is, and then we're going to essentially figure out how many bits we need to allocate in total. Again, great if you want to hit a particular file size. What we're then going to do is we basically want the integral of the entire bitrate curve, so the sum of the bits, because this is like bits per second, we want the sum of the bits to be a particular value. It's going to look pretty similar to CRF, but instead of picking constant quality, our resulting file size will be similar. So just like that, we'll be able to have fluctuations. Now, realistically, the fluctuations for especially one pass are very, very small. You'll rarely see encoders do these big, massive jumps in performance. But, you know, our quality will be roughly consistent. I'm just going to drop with a bit of wiggle. So this is also a very good scheme to follow. Now, how do you use these different modes in something like FFmpeg? Well, FFmpeg has a couple of modes. First, I can provide, so if I want CRF, I just provide a dash CRF in my video. Most new video formats support this. X264, X265, BP8, BP9, AV1, they all support CRF-based encoding. And again, the values go from 1, usually all the way up to like 60. The lower, the better quality. The higher, the worse the quality. But the smaller the file size. Next, so if you want CBR, usually you provide a bitrate, but generally you need to also provide a min and a max. These are usually dash min rate and dash max rate. So basically you need to force the minimum and the maximum to be the same. Otherwise, if you just give it a BV, it's going to revert to what is one pass. So then one pass is you give it a CRF usually, and target the maximum bitrate. So this is also called constrained quality, because we're going to try to go for constant quality, but it's constrained at some limit where we don't want to pass it. Now, on some codecs, if you provide just dash BV, it's actually going to use one pass, not CBR. That's because CBR is very inefficient. If there's nothing moving, it's a still picture that you have on screen, you don't need to encode that many bits for it. So what's going to happen is if you just give it a BV, it's just going to hit as high of a quality as it can usually. Next is two pass. Again, this is usually very slow. Usually you can give it, it can take in a number of parameters. You can usually give it, if you want to hit a particular file size, you will give it a target bitrate. And the bitrate is determined by the length of the movie over the bitrate, and that's going to give you like how many bits you should allocate, right? Or sorry, times time. So if you know that you want a 1 gigabyte file, and you know your movie is, or your video is like 1 minute, well, that's 1 gigabyte over 1 minute is what bitrate I want to target. And 2pass will make sure that on average, if you average out the whole video, your bitrate is this. But it's going to give complex scenes more bits and take away those bits from scenes where they aren't needed. So it's essentially going to go Robin Hood and distribute out the bits for us. 2pass, usually you need to provide dash pass 1 for your first pass and dash pass 2. So you will have to run FFmpeg twice. The first pass is going to generate a temporary file that saves the analysis of how complicated the video is. And the second pass is going to use that generated file and set the bitrate accordingly. You can usually define, the output of this is going to be an empty video file, so you can just send it to dev/null. All that matters is that intermediary file that's made. And finally, I guess I'll just mention constant quantization. That's done with usually -QP, quantization parameter. Generally, avoid it. If you want a fixed bitrate, you should go for this. Otherwise, go for CRF. I usually like to, as I said, use CRF since it results in what, to my eyes, looks like pretty consistent quality. Although the exact specifics will depend on which encoders you're using. I'm going to leave it off here for this video. In the next video, I will talk about the difference between what happens to each of these as we adjust the speed. So FFmpeg has preset speeds usually for X264 and X265. And I'll show you what happens if we increase the speed versus decrease speed in each of these. And usually it's either you sacrifice quality or you sacrifice the bitrate. Hopefully this helped you. Hopefully this has given you a good understanding of the essentials of the different video encoding types, what they all mean on FFmpeg, and why you might want to choose one over the other for particular applications. Thank you for watching.